This webinar is part of the Partner Country Initiative between Latvia and Germany. Every 3 years, the Federal Union of German Library Associations chooses a new partner country. And since the summer of 25, so almost a year now, Germany has a partner country initiative with Latvia. And we established this webinar series in December last year in order to have an opportunity where we exchange on a specific topic ideas and discuss them and learn from each other. If you want to know more or get involved with the Partner Country Initiative, there's different ways. You can go to the German website of BII International, and there's a whole section on the Partner Country Initiative. There's also a mailing list on this website that you can subscribe to, or if you want to join our fine working group, we meet once a month digitally. Please send me an email. That would be international@bibliotheksverband.de. And for the Latvian side, there's also, of course, ways to get involved and learn more. There's the website that you see here, or if you want to join, you can also contact Viktoria Piščikova from the Latvian National Library. So today's topic is digital transformation and AI. The viewers of the last webinar choose this topic at the end of the last webinar 2 months ago. And we're very happy to have 2 fantastic input givers today. We will start off with Matīss Bolšteins of the National Library of Latvia. He is the head of data management development at the Institute of Bibliography, Data and Knowledge Management at the National Library of Latvia, as I said. And he will speak today about AI in cataloging and improving metadata quality. And he will be followed by Dr. Argie Kasprzik, who studied computational linguistics, computer science, and cognitive psychology, and holds a PhD in theoretical computer science. They have been coordinating the automation of subject indexing using methods from artificial intelligence at ZBW. That's the Leibniz-Informationenzentrum for Economics in Germany since 2018. Dr. Kasprzyc's interests encompass various approaches from artificial intelligence, notably semantic technologies, machine learning models, and the question how those various AI branches can be interlaced in a useful and sustainable way for the purpose of knowledge organization. So these are the 2 inputs. We usually let the input givers speak for approximately 15 minutes each. And only if you have really burning questions of understanding and cannot follow the presentation further unless you have asked a question, then of course you can ask a question in between. But normally we let the presentations go through and then in the end get into a discussion. And as Victoria said, we will record the session also, so the recording will be available on our respective websites in Germany and in Latvia. You're welcome to turn your camera on or leave it off, and you can also ask questions either by raising your hand and speaking or by writing them into the chat. And with this, I will hand over the digital floor to Matīss Bolšteins. Please, the floor is yours.
That's great. Great to know. Now it's on. Okay. So good morning again. My name is Matīss Bolšteins, and I work at the National Library of Latvia as Head of Data Management Development. And today I would like to share our practical experience with AI-assisted cataloging and Mark 21 metadata generation. I hope most of you know Mark 21 because rather than focusing on cataloging theory, I will show how we currently use generative AI tools in our workflows and what challenges we have encountered. So why AI in cataloging? At the National Library, we have more than 600,000 monographs or serials that remain undiscoverable in the electronic catalog. So we are looking to speed up the retrospective cataloging process. So this was our first step. And on the slide, there are some examples of the resources we have to catalog. Uh, over over the last few years, libraries have increasingly started experimenting with AI-assisted metadata creation. National libraries in countries such as Belgium, Norway, and Denmark are already implementing AI-supported workflows. At the same time, there is still relatively little systematic evaluation of how well large language models comply with MARC 21 requirements and cataloging rules in general. And we also should keep in mind that AI should not simply be adopted because it is available. We need evidence-based implementation and a clear understanding of strengths and limitations. So our first question was straightforward. Can AI help catalogers create bibliographic metadata faster while maintaining sufficient quality and consistency? However, measuring faster is not straightforward in cataloging. The introduction of AI affects workflows, staff practices, prompt development, and quality control, not just the metadata creation process itself. And for that reason, I focus on a more specific and maybe measurable question. What are the main format and structural conformity issues that may arise in large language model generated MARC 21 bibliographic records? And by identifying where and how models fail, we can better understand how AI can realistically support cataloging workflows and also where additional human intervention is needed. The first AI-assisted workflow was adopted by our catalogers about a year ago. The process is relatively simple. The cataloger photographs the bibliographic information using a phone. Then ChatGPT generates a draft record, and then the record is copied into a text file and imported into our library information system, Aleph, and then manually reviewed. Of course, the cataloger still needs to verify the record, link added entries, and make any necessary corrections to the record. Catalogers work directly with ChatGPT using a shared project environment, and the project source contains a MARC 21 record template supplemented with cataloging instructions. I will show the file a bit later in the next process. But here is an example. As you can see, the model is able to extract bibliographic information from the title page or the other side of the title page, and it can structure it according to MARC 21 and Aleph sequential format and create a draft record for us. And every generated record is reviewed before being added to the catalog. And we also include a note indicating that the draft record was generated using AI assistance. It's the 590 field here. Here is another example, more like our general retrospective workflow, but the idea is the same. While the ChatGPT workflow is useful, most retrospective cataloging materials arrive to us in large batches, and with the original workflow, every resource had to go through the same sequence of actions individually, taking a photo, copying and pasting the output, saving a file, importing a file, and none of these actions are particularly difficult, but repeating them hundreds of times becomes inefficient. So this led us to develop a batch processing workflow. Instead of processing one resource at a time, multiple resources can be submitted simultaneously and processed in a single run, reducing the repetitive manual work. Now we have, so this is the original workflow, but now we have a table scanner connected to a computer. So the phone is eliminated. Resources are submitted in batches, like scanned and submitted in batches, processed only once, and the generated MARC records are returned for one import, not hundreds of times. So I will show now our batch processor tool. I need to turn this off. And then, so yeah, this is the tool. Unlike ChatGPT, this tool uses an API key. I have deleted it, so you don't see it. But for our current usage, this is actually cheaper than maintaining subscriptions, because beforehand we maintained a few subscriptions for our catalogers, and this just is much cheaper. And we have also more control, and we can see how many tokens does it take for our needs, and it's much more manageable. The same cataloging prompt is used here. It's the same prompt I told you before with instructions. We have written it in English because in Latvian it doesn't understand very clear what we need. And the cataloger specific settings and information is stored in the tool, so they don't need to be entered every time. The only requirement is to keep the individual folders organized. The tool is connected directly to the drive in our computers, and where we scan the title page, where the scanned title pages are stored. So I can show you an example of a folder you now, I hope, see, but I open a folder, and here I have scanned resources. And once I have scanned my portion of resources, here is 15 of them, and I can go through them. So once I have done that, I can move to the batch processor tool. I select my folder and just submit a job. And then when processing is complete, the output file is automatically saved to the drive again and can be imported into Aleph with a single operation. So we have taken out a lot of clicking from the previous workflow. So now I just chose a file from the result folder and convert the results. It sometimes takes a bit more time, but usually like a half an hour, probably almost, maybe sometimes even 10 minutes or 5 or 3. But yeah, we now have the 15 records here, and we can go through them individually and click to edit, and then we can go through everything in our system. So that was the workflow demonstration. I will get back to the presentation with some challenges and observations. Some are typical large language model issues, prompt sensitivity, hallucinations, and the limited transparency of model decision making, and also how, again, ChatGPT was like how it works. We don't even have a clear idea. And others are cataloging specific multilingual resources, unusual publications, and local cataloging practices. One common issue was that some models occasionally generated explanatory text outside of the Aleph sequential Mark 21 record, and our system interpreted that this as an invalid content and split the file into multiple records. Here they are marked with question marks, and the record is usually recoverable, but it introduces an additional manual step where you have to look up the file. This problem we have it's been dealt with. It doesn't happen anymore, but some models tend to explain themselves a lot, so we don't use those. Then field 008 proves to be particularly challenging still. Here we can see 3 different models generated different values for the same publication. Some values are missing, some are misplaced. Here on the second one position, and the third one, it just ignored the first, like the date. And this is a problem because parts of field 008 cannot be edited easily in Aleph. They cannot be edited at all. And some of them you have to edit manually, and these errors become especially problematic. Then there was our prompt explicitly instructs the models to leave the physical description field 300 blank because it cannot be implied from scans of the title pages. Nevertheless, some models might sometimes add physical description information. And once, while presenting these results to my colleagues, the audience asked whether the model looked up the physical information data on the web. No, it does not. Here is the real physical description. This is a complete hallucination. It seems plausible, but it's not factual. So we don't, in our prompt, we say that leave leave this field blank. Don't add anything to confuse the cataloger. And it doesn't add much. So yes. Our prompt also instructs the model to show added entries in uncontrolled added entry field 720, not 700. The catalogers can check if there is a linkable authority file in Aleph. If there is, it automatically becomes 700 and adds subfield D. So we don't need models generating subfields D. It's also confusing the catalogers. They could rely on the generated informations. And also, we didn't ask before to add subfield 4, but the models tend to do it anyway. Maybe they have learned from other mark records and see that it's usually there, and then just override our cataloging instructions. But we have revised our the prompt for added entries based on the results. We can see here that multiple persons were added to the same field. We didn't like that. There are also some notes added here in Russian. We don't need that. We use roll codes, and we don't catalog. The cataloging language is Latvian, so we don't need like too much Russian in our records. And based on these kind of results, we revise the prompt regularly. So we have also encountered numerous smaller inconsistencies, missing punctuation, omitted dates, invented values, missing diacritics. Latvian is challenging, and occasionally completely unrelated information appearing in local fields. And none of these errors are catastrophic individually, but together they increase review time, and we don't want that. Finally, one of the more interesting observations concerns transliteration. In some cases, Russian language publications were automatically transcribed using Latvian orthographic conventions. These records are pretty much unusable. We don't need, because we transcribe, we don't need transliterated these kinds of results. And like here, izidanie, it's like in Russian, but here it's written in Latvian letters. And like, how would you pronounce it? Yes. So these records are completely unusable, and the cataloger needs to write themselves and do everything themselves. Okay, and to conclude, AI-assisted cataloging is useful, but it cannot replace catalogers. Hallucinations occur, instructions are not always followed, and consistency cannot be guaranteed. Results indicate the need for prompt revisions, and we do that, but models may still fail to follow instructions in unexpected ways. Here is the list of references. I think we will share the presentations also, so maybe someone wants to look at them. But the tool which I have shared, the batch processing, it's not available outside the library drive. So I can add the tool which it is based on, like the programming and everything that is on GitHub. But yeah, thank you for your attention. And that's it from me now. I will be happy to answer the questions after the next presentation. Yes?
Thank you, Matīss Bolšteins, for this interesting presentation. And yes, I would say we go right on to Dr. Argie Kasprzik. Please, the floor is yours.
Okay, perfect. Thank you. I just spontaneously added a slide because I think one of my important messages in other talks that I give is always don't just say indiscriminately AI, because it's important to recognize that AI is a wide field with a lot of methods, and most of them have existed for decades, even 70 years and more. So, and machine learning is a small subdomain of AI, and in there you have neural networks, and in there you have generative AI and or also large language models. Not every large language model is generative, by the way. So I think it's very important to always say which methods we mean when we talk about AI. And at my institution, at ZBW, we have been thinking, so my predecessors have been thinking about automating subject indexing since, let's say, almost 2000, so for over 25 years. But there was a serious predecessor project called AutoIndex until 2018, where they decided to actually have a full PhD position within the library to develop the machine learning methods that we need, and also to only use open source, to not work together with commercial providers, which is very important for us. So, and that continues until this day. I would not work with products from big tech, such as OpenAI or Meta or Google. But we actually managed to convert the status of the project into a permanent task, and that has a very real consequence because in addition to the team lead, which is now me, and the PhD student, we got a third position, which is the software architect, and we managed to actually build a machine learning-based automated subject indexing service, which runs productively since 2021. And the PhD student is continuously checking what kind of methods are now en vogue in the domain of artificial intelligence, of course, including language models, small, middle-sized, and large language models. And we check what we can integrate into our service in-house. And the data flows look like this. So we have our AutoSE service productively running at the bottom left. And we actually check our metadata record base every hour to check if there are new metadata records that we could enrich with subject indexing, and if they fulfill our criteria and our output passes our quality filters, then we write it back immediately. But we also provide our output as suggestions to the platform where our subject indexers, the human subject indexers, are still doing the intellectual subject indexing. So this is like computer assisted or machine assistant subject indexing. And the indexing of the subject indexers goes back into the union catalog, which is then mirrored into our database, where we immediately fetch it so that we can compare our output to what the humans actually indexed and how we performed in comparison to that. Some facts and figures. So currently we're only working on English publications because we are a large scientific library for economics. And so most of the papers are in English. That's around 2/3 of the holdings, but we are planning on indexing more languages. Currently, we're working on very small snippets of text like titles and, if available, author keywords. And we're experimenting with abstracts, but I'll say some more about that later. And last month, we had over 2.2 million subject indexed metadata records. That's kind of 1/3 of the holdings and a bit more than half of the English language holdings. And we, as I said, we also display our suggestions in the platform where the intellectual subject indexing is done. And on the left, subject indexes can see some key metadata, and on the right, they get suggestions from us, which are clearly marked as machine generated, and they can then click on the green plus to adopt them, or they can just leave them and reject them. What we've also done, because that's very valuable for us, we have cooperated with the provider of this platform, which sadly is still not open source, but that was not my decision. But they are a small startup who agreed to work with us and to include an assessment tool. So right after the subject indexers have done the subject indexing and they are familiar with the resource, they also have to assess our suggestions, both on the level of the descriptors. So for each descriptor, say, okay, that was completely correct, that was a bit beside the point, that didn't fit at all, and also on the level of the document to say, okay, the subjects were okay, but some were missing or they were too general, something like that. And then they send this into a database where we can fetch it and use it to improve our services. And one of the core components of our productive service is an open source platform called UNIF by the National Library of Finland. And even when they started developing this, we were already in communication with them, and we still exchange ideas and contribute to the open source development of this UNIF tool, which offers a way to pretty easily train machine learning methods and evaluate them. One problem is a bit that now we, and later on also the German National Library, started to use this in big productive system, and that clashes a bit with the ambition to be easy to use. So we still have to check if our very complicated requirements are compatible with this ambition. The other thing is it is open source, and some of the libraries that UNIF uses might just fall out of maintenance all of a sudden because the one person sustaining it moves on or does something else. So it really requires a community effort to keep these libraries going. And as for the methods we're currently using in production, we combine established pre-transformer machine learning methods, including one model that we developed in a so-called ensemble. So you don't just use one model, you use several, and only if they all agree, more or less, then you use the output. And we also have a subsequent applications of quality filters and rules. So we don't just use the output as is. And we have some more components built around it, also automated quality control, which is also machine learning based. And the overall performance is an F1 score of 0.6, which is pretty astonishing because human subject indexes only agree to about 30 to 40%. So I would have expected that we have a level at F1 score of 0.3 or 4, but the machine is a bit more consistent, so this is pretty decent. What we're also doing right now is we're analyzing how our data fits together with our models. So, for example, we did assume that using abstracts would add valuable semantic information and therefore help in training. The problem is, and I think that's a problem that many libraries have, less than 10% of our available metadata records have abstracts, and some are in the wrong language, and abstracts are not language typed separately from the record. So that caused a lot of problems, and actually in the first experimental results that we had, we saw that using abstracts would actually hurt our performance. So the lesson is know your data before you choose your model. And also our PhD student Lakshmi found out how our model choice interacts with our controlled vocabulary, which is a standard Thesaurus Wirtschaft, standard Thesaurus for economics, and saw that for almost 40% of the mistakes that the machine made are on labels that have very little training data available. So if a label is not represented well in the training data, the machine still struggles. And also a machine often suggests more general subjects because the general subjects are just more present in the training data, and that's a problem. Now, since we were already talking about large language models, so we did want to know for the task of generating descriptors from a controlled vocabulary, which works better, our productive machine learning models, which are fine-tuned on our specific library data, or an open weight LLM. So open weight is still not open source, so that's open washing by companies like OpenAI and Meta, but still better than a commercial product. But we checked this, and the preliminary result is overall our productive model, even with the pre-transformer models, wins. So they perform better for subject indexing. However, that changes in the tail labels. That means in the labels that are not represented well in the training data, the LLM has the property that it makes wild guesses, but that means it hits luckily more often. So it's kind of it's a gamble, and it sometimes pays off. And we can use that, but that would mean that right now what we're doing is trying to train different model on different areas of the training data. So for things that are very well represented, we can use our models. And for the tail, we might use large language model-based solutions. So right now, we're also experimenting with one new feature in ANIF, which means that I can train a model separately for different areas of the vocabulary or different groups of labels. For example, for us, geonames are very important. And for tail labels, so we're experimenting with large language models. We are also experimenting with, let's say, small language models, which are transformer-based, but not these enormous foundational models like X-transformer, and one that's called embedding-based model by German National Library. And we might experiment also with synthetic data. So we're trying to artificially augment our training data a bit. And active learning, which means that there's one algorithm that decides that this and this metadata record would be very valuable if a human annotated it, because then the machine can learn from it. So we can change our priorities a bit in training. So this is the last slide. Some lessons learned is, first of all, that productive operations need long-term commitment by the institution and not a series of some tentative projects, especially if it involves AI, because right now everybody's saying, oh, AI, we need to do something with AI. Let's do a project. And that never amounts to anything if you don't have the resources to keep it going. And I would still say for special use cases and data sets such as those in libraries, which are very eccentric, there are no shelf-ready solutions yet, no matter what providers tell you, and personnel with varied expertise is needed in-house to develop those, open source preferably. And even and especially generative AI needs to be combined with curated high-quality metadata and document bases. And not everything needs an LLM. Often a combination with a smaller, specialized automation solution works just as well or better and consumes less resources. Because the commercial LLMs, what they are doing to the planet right now is unfathomable. So I would say we should, as libraries, find our own solutions because it's reconcilable with the values of libraries. That is my input to your discussion.
Thank you very much. Wow, what a ride. Thank you for both your presentations. Yeah, so now it's time for questions, feedback. As I said before, feel free to either raise your digital hand or write something in the chat. Maybe I start with a question to Matīss Bolšteins. So you mentioned ChatGPT a couple of times, but you also in one of your slides showed different models. So is it mostly ChatGPT, or do you use Claude and, I don't know, Gemini, etc. as well? And if so, like, why did you choose whatever you mostly choose?
Yeah, mostly we use ChatGPT because it had like better results in my experiments with the three models that I showed. I have tested more, but these were the top when I did the experiments. I also want to clarify that we never give like full texts to ChatGPT or any model. We only use the title pages or no, like bibliographic information. And because that is also a concern, we had a concern, but we have like dealt with it. I did the most of the experiments in October. That were the models that I used, and based on the results, I gathered that OpenAI model like did better in cataloging because Google just does what it thinks it without any like reason, like too much hallucinations and yeah.
Okay. Yeah, and speaking of hallucinations, so you mentioned review time at some point, but like how much time or yeah, would you say goes into double checking the generated cataloging data that you get out of the machine?
That is the tricky question because everyone asks that, and it's like
But would you like, do you check everything or no? Probably
we
not,
have
'cause
like we definitely check the coded fields because we know there could be problems. We know how to work with the retrospective, like pretty much everything is in Russian and not many personnel wants to work with that. And we have like tips and tricks we have like learned because to check something like sometimes it's the orthography. It uses the Russian I is different in older times than now, and if it uses like a Latin I, it doesn't. Because everything is underlined in Russian, and we can see like where it isn't underlined, and maybe there is a problem. And we just know the most like the problems that can occur, and we like check those places. And yeah, but about reviewing time, it's just more efficiency for the person. You don't have to know the Russian keyboard to write down the whole every field. And also one other thing, we don't use this really for subject indexing. For subject indexing, we also have looked into ANIF, but different colleagues work with that because we have, until now, we had like bibliographic record happens at one department, and then subject indexing goes to another department. So we don't even like take subjects from the ChatGPT or something like that.
Okay,
I hope
thank
I
you.
answered something.
Yeah. Diana Rutzite.
Yeah, hi. I have a question for the Matīss. MI changed so fast, and does it affect your experiments? You discover something that works, and tomorrow it's not.
I think there was with the transliteration in my experiments, OpenAI models never like transliterated in the Latvian language, like transcribed in Latvian letters. But now I have heard that the newer models tend to do that. So yeah, not everything is predictable. So I like the Google and the cloud versions transliterated, and I thought that no, it doesn't work for us, so we shouldn't use those models. But now the new ChatGPT version does that, so we have to see what's going on. And
Okay, did that answer your question, Diana? Yeah. More questions, and while you think about it, I have one actually for Argie Kasprzik. So you did mention a sort of cooperation maybe with Finland, but I'm wondering, I mean, there's so much brain power that goes into these projects, or not projects, but you know, like the development. From your experience, I mean, do libraries and institutions work together on this? Do you reach out to other institutions to share your gains and your experiences?
Absolutely. So I'm very aware that, so we are a library and also a research institute, so we can afford to have even this one PhD students. I'm very aware that smaller libraries cannot afford that. So it's pretty important, I think, to have one competency centers that can do stuff like that, like develop open source models for others. And two, we need to cooperate on this. So we cooperated with the Finnish National Library first, and then the German National Library came along. And right now, for example, we're sharing the burden of this open source development and the responsibility mainly between our three institutions. But at each institution, we're also just teams of, let's say, 3 to 5 people. And that's like a bus factor of 1. If one is hit by a bus, the project crumbles. So we're seriously understaffed, and it's very, very important to build these corporations, but also to do some political activism so that this is funded more, because that's the only way to survive. You can't just do it as a single library, especially not if you're a small university library or something like that.
Okay, so but that means also other institutions reach out to you and
Yeah, I'm giving a talk like every 2-3 weeks to international and national players who want to get into the game. Yeah.
Okay, interesting. Okay, there's a comment or question in the chat. Where will the recordings of this meeting be accessible? Also the presentations. Well, for the German side, it's on the BII website. For Latvia, Victoria, can you maybe say where you will put this?
Yes, it will be Bibliothek LV. I'm now typing the links. It will be under the news for this webinar, and I will also type the YouTube channel of the VDB. Good.
Okay, and then it says Matīss said he would provide the link to GitHub. I guess that's just a statement and not a question.
Yeah, and do I put it in the chat or we have something else we do that?
You could, but we would also later provide it on the mentioned websites. But yeah, feel free to put it in the chat as well.
Yeah.
Okay, do we have more questions? I'm aware that today's topic and presentations were quite complex, maybe the most advanced yet of this webinar series. But maybe you still have questions or comments, maybe also on the broader subject of AI, machine learning. Feel free to ask, comment, speak.
Yeah. I have a question about bibliographic records. What is the norm for our specialists to make manually, just without AI? And how many then could be processed with AI help daily?
A very controversial question because even the manual work, like norm, cannot really be set. I think it's like 10 or 15 a day, but it really depends on the resources that have been provided, because some of them are like 10 resources that are pretty much the same, and then you just copy catalog. And if there is like 5 resources that are completely complex and then it's more time. But we have not set a goal of AI cataloging like norm, because of the reason like every resource is different. But I can see how much resources are in the folders that everyone is submitting, and it's between 7 to 15, and every day it's different. So yeah, but in statistics, maybe we have like I have heard that it's better, like 13% like more records than the year before or something like that, but I should check the number.
Maybe I can answer the same question for subject indexing.
Yes.
So I don't know. I don't know what the rate per day is, but we still have 7 people who are intellectual subject indexers, and the number that they could do per year was steadily declining. So right now they are doing maybe something like 15,000 records a year. While our productive service does like 200,000, 300,000, depending on what comes in. So there's a big gap between the two. The one problem is that, of course, the subject indexers are saying something like, that's great. If we have a productive service, then we can stop subject indexing and or also focus on the things that are really important to subject index. On the other hand, the less they index, the less we have training data. So that's a bit a catch-22. So we have the problem that it's really, if people retire, then the jobs are not filled again with a subject indexer, but somebody who's like more technology oriented and doing some innovative product or something. But that's a bit of a problem. We still need the human expertise, but we need to focus it precisely because it's so valuable and so rare. So
I can add to that one problem we had. We had a new worker, and we showed them the AI cataloger, and it was a mistake because you have to know the basic cataloging rules, and you have to be an expert to check if the generated record is correct. So now the person relies on they learn to rely on AI and then check, but you have to be an expert first and then you can check. And also the story is pretty much similar for us for the subject indexing. There are a lot of opinions, and it's not simple. And also one other thing, for the amount of resources per day, you have to also take into consideration that the catalogers need to also check for duplicates, and maybe they can copy catalog something else. And yeah.
Okay, thank you. Yes, and Victoria already wonderfully put in the web addresses, both for the German website and the Latvian website, where we put all the news of this partner country initiative and also the recordings of this webinar.